Hello friends, today we will discuss superposition theorem. So first we will discuss the statement of superposition theorem. It states that the current through or voltage across an element in a linear circuit is the algebraic sum of the currents through or voltage across that element due to each independent source acting alone. So now, what is a linear circuit? A linear circuit is nothing but it is a combination of the elements which are having linearity property. So now we will learn what is the linearity property. Basically, this linearity property is the combination of two properties. First one is homogeneity, which is also known as scaling, and the second is additivity. Now we will learn about homogeneity. So when we look at this equation in which V is directly proportional to I, it means that if we scale the current by n factor k, then output will also increase by the same scaling factor. Or if you write the Ohm's law, which is saying resistance R is equal to V upon I, where this R is constant, if you will scale the current by n factor k, or you will increase the current by n factor k, then for resistance to be constant, this V should also increase by the same factor. So this can be written as, if we multiply the current by n factor k, then the output should also increase by the same scaling factor k. Now we are moving on to the additivity. Suppose the output V1 is equal to input current I1 into R and output V2 is equal to I2 into R. If we will apply the input current in a circuit in such a way that input current is the sum of I1 and I2, then the output of that circuit should also be equal to V1 plus V2. So here it will appear like this. Now we have applied the current in any circuit like I1 plus I2, which is the resultant of these two, into R. If we will open this is I1 into R plus I2 into R, where I1 into R is V1 and I2 into R is V2. So output is also V1 plus V2. It means that if the input current is the summation of two input currents, then the output should also be the summation of two outputs that are created due to each individual current. Now, what are the steps required for application? So turn off all independent sources except one source. Find the current or voltage due to the active source. Now follow the step 1 for each independent source. Find the resultant current or voltage by algebraic sum of current or voltage. Algebraic means sum with their direction in case of current and polarity in case of voltage. Now the key point to remember: turning off an ideal independent voltage source means replacing the voltage source by an short circuit. Turning off an ideal independent current source means replacing the current source by an open circuit. Now the third point: leave dependent sources intact as they are controlled by circuit variables. And last point: turning off an independent source means replacing the source by their internal resistance. This point I have mentioned especially if the circuit is given with their internal resistances, then you do not have to replace an voltage source by a short circuit. You have to replace by that voltage source or current source by their internal resistance. Here we are doing short circuit because of ideal nature, because ideal voltage source have zero internal resistance. Whereas in case of ideal current source, internal resistance is infinite, which means open circuit. Now let's have an example. So here in this circuit, we have to calculate the value of voltage in 2 ohm resistor with the help of superposition theorem. So here in this circuit, there are two sources, one is current source and another is voltage source. So we will step by step apply the superposition theorem. So step first says that turn off all independent sources except one source. So here we will consider 10 volt voltage source first and we will turn off this current source. So we will redraw the circuit and the circuit will appear like this. So here we have considered 10 volt voltage source. As we can see, these three resistors are in series with this voltage source. Now we can calculate the value of V1 by voltage division rule. This voltage division rule is always applicable in a series circuit. So V1, which is the voltage across 2 ohm resistor. So the value of the resistor in which we have to calculate the value of voltage divided by sum of resistances. So 2 plus 3 plus 5 into supply voltage, that is 10 here. So 10 and 10 will cancel out. So this is 2 volt. The important point is to note here, check the polarity of the voltage. In the circuit, the current will flow in the direction of arrow. So current always flow from higher potential to lower potential. So positive will come here and negative will come here. Now we will consider another source, which is a current source of 8 ampere, and we will turn off this voltage source. So here we will redraw the circuit and circuit will appear like this. So here the voltage source is replaced by a short circuit. Now we have to calculate the value of voltage V2 in 2 ohm resistor. So first what we will do, we will calculate the value of current in this resistor and we will apply the Ohm's law to calculate the voltage. So first we are calculating the current in 2 ohm resistor from current division So suppose that current is I. So I is equal to the resistance of the branch which is in parallel with this branch. So this is the resistor 5 which is in parallel with this branch. So 5 divided by this 5 plus 2 plus 3 into supply current, the current which will divide into two branches. So this is equal to 40 divided by 10 is equal to 4 ampere. Now the voltage V2 is equal to, from Ohm's law, current into resistance. So 2 is the resistance into 4 or the value of I. So 2 into 4 is equal to 8 volt. Now we will check the polarity of V2 as the current is flowing in this way from top to bottom. So positive will come here and negative will come here. As we know, the current always flow from higher potential to lower potential. So in both cases, the polarity of V1 and V2 is same. So we will write from superposition. So from superposition, V is equal to V1 plus V2, which is equal to 2 plus 8, 10 volt. So what we will do, we will consider this current source first and we will replace this voltage source by a short circuit because this is the ideal one. So we will replace this voltage source by a short circuit. So circuit will appear like this and the direction of the current is indicated by the arrows. So first, suppose the current in this 5 ohm resistor is I1 dash, the current in this resistor is I2 dash, and the current in this resistor is I3 dash. Now, as you can see, this 2 ampere current source will start from here and will move till this point. After that, both the element having same value, so current will also be same through both of them. So the value of I1 dash is equal to 1 ampere Similarly, the value of I2 dash will also be 1 ampere. Now, the current through I3 dash will be equal to 0 because it is in parallel with the short circuit. So all the current will pass through the short circuit. Now you can prove it by the current division rule. So I3 dash is equal to the resistance which is in parallel. So the resistance of parallel branch is 0, as we all know. The short circuit having 0 resistance. So 0 divided by 0 plus 10 into the current which will divide. So that will be I1 dash. So this will be 0 ampere. Now we will consider this 10-volt voltage source and we will leave open this current source. Now this will be the circuit and the direction of the current is marked by the arrow. So now, as we all know, this branch is having the 10-volt voltage source in parallel, and these having the value of voltage 10 volt. So this is open circuit. Now suppose the current in this branch is I1 double dash. The current in this resistor is I2 double dash, and the current in this element is I3 double dash. So first we will calculate the current I1 double dash. This will also be equal to I2 double dash because both the elements are in series. So this is equal to 10, which is the voltage, divided by resistance 5 plus 5. Both are in series. So the current will be 1 ampere. Now we will calculate the value of I3 double dash, which is equal to 10 divided by resistance is equal to 1 ampere. Here, this is the Ohm's law we have applied here. Now we will calculate the value of I1, or which is the current through 5 ohm resistor, or the current in 5 ohm upper one resistor is equal to I1 dash minus I1 double dash, because both the current having opposite direction. So I1 dash minus I1 double dash. So this current will be equal to the value of I1 dash is 1 minus the value of I1 double dash is also 1. So the current in the 5 ohm resistor, which is top one, will be equal to 0 ampere. Similarly, the current I2 in the 5 ohm resistor in lower one is equal to I2 dash plus I2 double dash, because both are in same direction, will be equal to 1 plus 1 is equal to 2 ampere. Now the current I3, which is in 10 ohm resistor, is equal to I3 dash plus I3 double dash is equal to 0 plus 1 is equal to 1 ampere. I hope the numerical is very clear. Thanks for watching the video.